Okay, so we're going to talk about area. Perimeter is like the distance around. Perimeter is like a fence, a perimeter fence. Area is like carpet. It's covering the surface inside the shape for two-dimensional shapes. For three-dimensional shapes, there's surface area of all of the surfaces added together and volume. But we'll talk on that stuff later for you. Let's talk about area, basic area. You did some before, squares and rectangles. Area for a rectangle, it was just length times width. One side times the other side, length times width, area equals length times width. We've heard it, we've seen it in the TV shows, we've heard it on the radio. It's in the movies. Length times width, area, rectangle. Cool, you got that. Square, the length and the width are the same. So, since area is length times width for a rectangle, area is length times width for a square. Because squares are rectangles. But since squares are special rectangles, where the side with the other side being the same, you can just say area is side times side or side squared. That's why they call the exponent where you multiply something times itself squared. The little a equals S2. That's such a hint. Area equals side squared. Squared, because they're the same size. What about a triangle? I don't know. Whoa! Let's think about this. Triangles are half of a rectangle, no matter how you go about it. Let's see this. So I'm going to take our standard rectangular piece of paper, 8.5 by 11, and we're going to cut one corner to corner, kind of like making sandwiches and cutting them into triangles. Leave the crusts on. That's more nutritious. But we're going to make triangles. We're going to make 3 kinds of triangles. Let's go. Okay, so 3 kinds of triangles. We're going to cut one corner to corner, have 2 right triangles. We're going to fold one down the middle and use that middle point as the center so that we have an isosceles triangle because the sides will be the same. Let's also do one that's a scalene triangle, just 3 sides different. It'll be easy to do. Let's make it happen. All right, so this one is my isosceles triangle. You can kind of see it started out as a full sheet of notebook paper or copier paper, whatever paper this is. I don't know. It's paper. Full sheet of paper. Fold it in half. Use that as the center to make 2 identical sides. The sides of this triangle are identical. It's an isosceles triangle. Folds in half nicely. Lovely. Now, the other 2 pieces, well, glad you asked. Look, this side is equal to that side, and this side equal to this side. It was up here, but basically, it's 4 identical triangles. The isosceles triangle is half a rectangle. Let's try another one. Alrighty, so we've got 2 equal bits. Makes a square, sort of, but it did make a rectangle. So, rectangle, triangle is half a rectangle. Right triangle is easy. It's half a rectangle. This one, it's a scalene triangle. None of these are the same sizes. I'm going to lay it out on the floor and show you what it looks like. All right, so here it is. This is a scalene triangle. None of the sides are the same size. This one won't match up there. This one won't match up there. And it won't match over here either. So none of the sides are the same size. But watch this. All right, so here's generally how our original looked. It was a rectangular piece of paper. Then what happens? And this one flips over too. Check that out. The scaling triangle is equal to half of the sheet of paper. All triangles are half rectangles. So I've just spent a lot of time talking about how all triangles are half rectangles. Why bother? Because you know how to find the area of a rectangle. The area of a rectangle is the length times the width, or the base times the height, however you like saying it. It's one side multiplied by the side that touches it. Could be this side, could be that side, could be up here. We multiply two sides together. That's our area for a rectangle. But the way that works is we're measuring two distances at a right angle to each other. You could measure the center across and the center across the opposite way. If those measurements are at right angles to each other, that's still going to be the number that you've got to multiply to find the area of the rectangle. Why are you talking about this, Mr. Starling? What was the point? The point was triangles are half a rectangle. Area of a rectangle? The area of a rectangle is length times width, or base times height. We could call it that. Base times height as the area of the rectangle. Cool, got that. Now, what did we say a triangle was? Half a rectangle. Okay, so there it is. If the area of a rectangle is the base times the height, and a triangle is half a rectangle, then the area of a triangle is 1/2 the base times the height. Is it half the base, half the height? Doesn't matter. You could multiply base and height and then divide by 2. It's going to come out the same either way. Okay, so let's give that a try. Here are 3 different triangles. What's the base? What's the height? The base and the height are always at right angles, 90 degrees, right angles to each other. The right triangle is marked with a little square in the corner. We know that's a right angle. So the base could be across the bottom and the height up the side, or you could flip them around. It won't make any difference. 2 times 3 is the same as 3 times 2. Cool. Now, what about these other 2? There's no right angles on there. Just pick an angle and make a right angle. Just pick one. Just pick one. Look. See? You can measure it across as long as you've got the side that's 90 degrees to it and the measurement to the corner, 90 degrees opposite. That's your base and your height. Over here, same thing. Base was across the bottom, height's up the middle this time, but the triangle isn't split evenly. This side is not the same length as that side. That triangle isn't split evenly. One side has more triangle and one side has less. That's okay. Base and height, it's still measured at a right angle. We're good.